Hey guys, welcome back to MathsQ. Today we are attempting the 8th and the last question from the International Advanced Level Mechanics M1, and that's of the Jan 2021. So without further ado, let's get started. So there's a very lengthy paragraph here to read. Now there you go. Two particles A and B, as you can see, that's A here shown here and B there on the other side, have masses 2 kg and 4 kg respectively. The particles are connected by a light inextensible string. The string passes over a small smooth pulley which is fixed at the top of a rough plane. The plane is inclined to the horizontal ground at an angle alpha, where tan alpha is 3/4. The particle A is held at rest on the plane at distance d meters from the pulley. The particle B hangs freely at rest vertically below the pulley at a distance h meters above the ground, as shown in figure 3. The part of the string between A and the pulley is parallel to the line of the greatest slope of the plane. The coefficient of friction between A and the plane is 1/4, or you can say mu is 1/4. The system is released from rest with the string taut and B descends, so you can say the initial velocity is 0 meter per second, and they ask us to find the A part is find the tension in the string as B descends, and it's of 9 marks, so we have to be very careful with our steps here. So to solve this kind of question, what we have to do is we have to go back to the question and look at the things they have asked us. They told us that find the tension. Okay, I have to highlight the tension in the string as B descends. So when B is here, I'll mention it here, and when B goes down, A moves apart with the same speed. You can say they are moving together, but we have to find the tension in the B part. So first things first, students, what we have to do is just eliminate the tan alpha and just find cos and sin alpha. And how to do that, just draw a diagram or a triangle, you can say. There you go, that's a right angle triangle, and they said that our tan alpha is 3/4. And if you remember SOHCAHTOA 2, which is a trigonometric identity used for finding sine, cos and tan, and we know that we have been given tan alpha, you can see it. So we have been given this part, I'll just highlight it. We have been given this part of the information, and we know that 2, or you can just say tan, or tan is opposite upon adjacent. As you can see, that's O stands for opposite and A stands for adjacent, so that's opposite upon adjacent. And we know from our diagram that our hypotenuse is this side, the longest side. The adjacent is on the bottom side of the diagram or the angle, you can say, and that's our opposite side, that's O. So what I'll do is I'll just plug in my values. It said tan alpha is 3/4, so my opposite is 3 and my adjacent, you can say, is 4. There you go. Now to find h, or to complete this diagram, what I'll do is I'll use Pythagoras theorem. There you go, a square plus b square is equal to c square. So always remember how, like most of the students, they make mistakes here and they don't know where to plug the c, b and a. Always remember, guys, the c is the hypotenuse, the largest part of the side of the angle, and b and a are the opposite or adjacent, or either way if you want to rearrange it. So don't get confused here. Just in time, I just replaced the c with h because we are finding the h, or hypotenuse, and I plugged in the values, which is 3 and 4. So now what we'll do is we'll just square these values. So there you go, 9 plus 16 equal to h square. Now some basic maths, adding them together will give us 25, and we know that we have to find h. So to remove the square from h, what we'll do is we'll just root both sides. So when we root both sides, the root and the square gets cancelled out, and we are left with h, and the root of 25 is simply 5. And now I'll just plug it back into the h. There you go, our triangle is complete. Now we'll be able to find the sine alpha and the cos alpha later on in this video. Coming back to our main answer, or to find the main answer, what I will do is we know that at A, the particle A, if we draw two lines here, there you go, and upside, always remember we have to solve the components or the forces, the horizontal and the you can say the vertical ones. There you go. Now the upward force I drew now, so that will be my R, or you can say the normal contact force, and the downward force will be the weight. Always remember your forces. And this side, or you can say the angle it's making, is the same as the angle there, alpha. There you go, and that's R minus W, you can say, or the angle which is making, I'll just label it. There you go, our downward force is W cos alpha. Now we know that W, or for the weight of the particle A, is 2 kg, so the weight will be 2 into G, or you can say mass into gravity, which is G. There you go, upward force minus the downward force, which is R minus 2g cos alpha, is equal to 0. And now what I'll do is I'll just make R the subject by adding 2g cos alpha to both sides, and now we can see that my R value is 2g cos alpha. Now to simplify the R value, we know that we can find the alpha values, or we can say the sin alpha and the cos alpha, just by looking at the diagram we have drew. If you remember so kaha tua, the cos, to find the cos we have ka, there you go, and that is adjacent upon hypotenuse, and we know that our adjacent is 4 and hypotenuse is 5, so that will become cos alpha equal to 4 upon 5. So we'll just substitute 4 upon 5 for cos alpha. There you go, R equal to 2g into 4 upon 5. Now I'll just bring my calculator up. Remember that the G value is 9.8, always remember that, and there you go, our R value is 15.68, or you wish to write 15.7, that's totally fine. Don't forget the units. The units for normal contact force or any force is newtons. Now we'll resolve the horizontal forces. So now we can clearly say that the tension in the pulley goes in this direction, always remember, towards the pulley. So either way for B and A, so that'll be towards the pulley, always remember that. And the angle it will make towards horizontal force will be sin alpha. And remember that we have been given the coefficient of friction between A and the plane as 1 upon 4. So what we'll write as force will be, so our force will be in terms of mu will be 0.25 R, because 1 upon 4 is 0.25 in decimal basis, and that's R. R has been already been given, that's 15.68 or 15.7 as you wish. Always remember that the normal force is the counterpart for the friction acting against the tension, you can say. So when the tension, or you can say the particle A moves in this direction towards the pulley, something in the opposite direction pulls it the opposite side, or it can be friction, and it can be the sin alpha angle that making it, or the weight towards. So what we can do is we can use the force equal to ma, you can say the formula. So T minus 2g, sorry about the sine angle there. There you go, T minus 2g sine alpha minus F equal to 2a. I'll just simplify it, but remember that we are finding T here. That's find the tension in the string as B descent. So in the B, so that's our first equation. We'll solve it simultaneously. So we'll find the tension for the B part also. Remember we have to eliminate A, that's acceleration, because we don't know the value for it. After simplifying that or multiplying the brackets in, or sine alpha is 3 upon 5, just plug it in, and then we get 11.76 minus 3.92, do basic subtraction. There you go, T minus 7.84 equal to 2a. Now coming back to the B part, so the particle B is traveling downwards and the tension is going upwards, and the downward force is much greater than the upward force, which is at tension, you can say. So the equation will be 4g minus t equal to 4a. Remember there are no angles for the particle B. Now what I'll do is I'll just add both the equation. Adding both the equation will cancel out the t, and our equation will look like, there you go, 23.52 equal to 6a, and to get a we'll divide both sides by 6. So our a value will be 3.92 meter per second, and just plug it back into the equation. Use this equation to plug in the value of a, because they said to find the tension in the string as B descends. So to make t the subject, what I'll do is I'll just take it to the other side, or add t to both sides and take away 4a. After simplifying the G and the A value, I'll get 24 Newton to 1 decimal place as our T value, or the tension. Just in case if you're wondering how did I get 23.52 in the previous value, remember that we had minus 11.76 from 2g into sine alpha, which was 3 upon 5, and 2g is 19.6. R value you already know, and then we added it to the 4g while solving the simultaneous equation.